Hello, everybody. So what we're going to be looking at today is going to be sums and the definite integral. Now, really, the definite integral is going to be more in the next homework set, like I think homework 27. Maybe I'm wrong, but this is specifically for homework 26, which is sums and the definite integral. So yeah, let's go ahead and get started here. So first of all, what are we talking about, right? Because we're on to a new topic here. So, what are our sums? So, of course, we know what sums are, right? Sums just mean addition. So, if I write out a sum, just a sum like this. So, let's just say sums. All right, what sums are we talking about? Well, lots of them, right? Like here's one. Here's a sum. 1 plus 2 plus 3 plus 4 plus 5, right? That's a sum. Okay. What's another sum? Well, how about a half plus a fourth plus an eighth plus 1 over 16? That's another sum. Okay. Why do they both like one does have, well, one has five things, one has four things. The number of things in there doesn't matter. But we can just add up as many things as we want. Okay. And the first thing we need to know how to do or learn how to do in this section is to write these in a shorter notation, right? Because if I've got something like this, like 1, 2, 3, 4, 5, let's say plus 6, plus 7, plus 8, plus 9, plus 10, right? You can grab a calculator and you can calculate what that number is, which I should have had a calculator, but I don't. So we'll do it by hand. But that sum is long. You don't want to write it. And so we need a better notation for it. Okay. And so the better notation is called either sigma notation, or sometimes people just call it summation notation because we're writing a sum. And what it is it's a shorthand for writing the type of sums that we wrote above. So we can write it in smaller, well, just smaller. That's kind of it. So what is sigma notation? So sigma notation is writing a sum in this format. So first you write this symbol. This is an uppercase sigma. Um, and then what you do, so sigma, Greek letter sigma. Then what you do is you have an index variable, which it's just a letter. So like they use K a lot, they use I a lot, they use N a lot. So like I'll do K equals 1. And up here, I'll put an N up here since I used K already, right? So what do these parts mean? So what we've got here is the K is just kind of an index variable. It's usually just called the index. Um, this is the starting um, value, I guess, starting index. And then at the top, you have the ending index. Okay. And so then you've got a formula here. So the formula, which I haven't written yet, but I'll write here, Fn. Nope, Fk, because I used K. Fk. And then this is just going to be some formula that usually is going to depend on the index variable. So some formula depends on the index, which in this case is K. Usually, it doesn't have to, but it often does. And so this right here, this is your sigma notation. Okay, now what does it mean? Well, let's try to write these sums up here in this format. Okay, so the first one, example, the first one was, I'll just say write in sigma notation. That's what we're trying to do. And the first one is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. All right. Now, the easiest way to write this is just to say, okay, we're going to write a sigma there. We need an index variable. So like k. What should k start at? Well, what number is changing as we move from this side to this side, right? Well, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number that's changing is just the number, right? That's all there is one number. So why don't we just use k to be 1 as our starting? And then our ending value could just be k equals 10. So k goes from 1 to 10. And then what's a formula for each of these numbers? So what's a formula that will go 1, 2, 3, 4 when k goes 1, 2, 3, 4? And the answer is just k. Right? And that's just the entire answer there. Right? And the way you would think about this, so let's just scroll up there so that's not on the screen. The way you would think about writing this out is you say k is 1, that's where you start. So you put the 1 into the formula, right? So you put 1, k equals 1 into the formula. And when you put a 1 into the formula k, you just get 1. And then the next thing you're going to do is you're going to put a 2 into the formula. Put k equals 2 into the formula. And when you put a 2 into k, you're going to get 2. It's a very simple formula, right? And you just keep doing this forever, not forever. You do it until you get to the stopping index, right? The stopping index is 10. So the last number that you're going to plug into the k is going to be k equals 10. So the last thing you do is you plug k equals 10 into the formula. So this right here, what I boxed, this is just a way to write out this same sum. Now it's kind of confusing. This is weird, a weird example because it's almost so easy that it makes it hard. It's almost easier when you have like an actual formula like you do here. So let's try that one. Get a color back. I think that's the wrong color. There. All right. So what was it? 1/2, 1/4, 1/8, 1/16. So 1/2, 1/4, 1/8, 1/16. So what you have to do is you have to think of a formula that could give you these numbers. Think of a formula first. And what you should realize is that 2, 4, 8, 16, those are all powers of 2, right? That's 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So they look like powers of 2. So we see powers of 2. Right? And so the formula, right, it's going to be 1 over 2 to the 1 plus 1/4, which is 1 over 2 to the 2, plus an 8, which is 1 over 2 to the 3, plus 1 over 16, which is 1 over 2 to the 4, right? So you see this. So you see this right here. And that's how you want to think of the 1/2 plus a 4th plus an 8th plus a 16th. Because now it's easy to write it in sigma notation. Because what you're going to do is you're going to say the 1, the 2, the 3, the 4, that's going to be your index variable, right? That's going to be your index. Okay? So then in sigma notation, you write your sigma. We'll say k equals 1, right? Because the index is starting at 1, and then it goes 1, 2, 3, 4. The index stops at 4. So 1 to 4. And then what's the formula? Well, every one of these things looks like 1 over 2 to the index. And that's your formula. So we're done. That's it. So that's your answer. Oops, I just erased the answer. So that's your answer. Of course, if you go backwards and try to write it out, it will make sense. Like if you take the 1 and you put it in here, you get 1 over 2 to the 1. And then the index goes from 1 to 2. You put the 2 in here, you get 1 over 2 to the 2. So 1 over 2 to the 2, 1 over 2 to the 3, 1 over 2 to the 4. And you stop at the 4 because the stopping index is 4. So that's it. This is the answer. This is just, kind of verifying that we have the answer we thought we had. Okay. And that's sigma notation or summation notation. And you're supposed to understand how that works. Okay. So what can we do with it? Well, there's a lot of different types of problems that you can use or you can solve. I'm going to look in the homework and make sure that we cover all of them, hopefully. Actually, looking at this, one thing that I see is that they really like problems where you're using the properties of sums. And so I'm going to give you the properties of sums, and then maybe we'll come back and we'll do more problems like this later if they give them to us. Okay, so let's look at properties of things in sigma notation here. So properties of sums. All right. So there's actually ways to combine the sums, right? If you had, well, you know what? I'll write them down and then we'll look at them. So here's a property of sums. So if you have a sum, they use I, I'll use I. Like, let's say 1, 2, again, we don't know what the stopping index is, so I'll just use n. And you've got some function here. So like, what's the function? I don't know. Let's just say fi. Now you could write it like that, or you can write it, this way, f of I. It doesn't matter. So don't stress about that. It's just a way to say the formula for f. And you add it to another formula for f. No, another sum, but let's say g, like that. Then that right there is going to be the exact same thing as if you did a single sum from 1 to n and you did fi plus gi in the single sum. So you can add a sum to another sum and get a single sum if you want. That's a property. Now, we're going to see how to use that in examples after we write down these rules, but this is where we're starting. Now, one thing you have to be careful of here is that like the starting index and the stopping index must be the same. So this one's 1 to n, 1 to n. This has got to be 1 to n as well. They all are the same. If one of them ends at a different place than n, like if one of them is 1 to 5 and one of them is 1 to 9, you can't add them up using this property. That's not a rule. Okay. What else can we do? Well, we could subtract them. Of course, that's going to be the same. Maybe I'll just do it this way. Plus or minus, plus or minus. Another thing we can do is we can add I goes from 1 to n of, what was I going to do? Oh, yeah, I remember. So if you have like some constant k, so k is not the index here. K is just a number. Maybe I'll use a c actually. C. And then you have a formula like this, f of I. What you can do is you can take the constant here. So this is where c is a real number. You can take the c out of the sum. So you can put the c outside and just leave the formula inside. And we're going to see examples of these, all in a moment. So don't get stressed out about that. All right, so we can add them, we can subtract them. What else can we do? Well, another thing we can do is we can say, here's another property. If I have a sum that goes, let's say, I goes from 1 to, gosh, how do I want to write this? Yeah, okay, I'll do it this way. So I'm going to say 1 goes from 1 to n, and there's a function there. I'll call it fi again. I'm going to change it. I want to use a different letter. I don't know why. Let's say ai. And then we add it to another sum, which starts at n plus 1 and goes to, let's say, m, just a different letter, okay? Also of ai, that's the same thing as if you did the sum starting at 1 and went up to m of ai. And again, we're going to look at these in detail momentarily, but we're just writing them down for now. What else can we do? There's these are the main ones that you're going to need in order to do problems, but there's also going to be a few others that are kind of useful. There's some simple ones. Here's a simple one. We could have started with this, but we didn't. If you go from I equals 1 to n, and you just have a number here, so let's just say c again. This is where c is a real number. If you think about what that is it's just going to be c plus c plus c, and you keep doing that until you get to the last one where you do. So basically you just do this n times. That's almost invisible, isn't it? Hold on. It is. Okay, let me erase that. Better color. Right, n times. And when you do c plus c plus c plus c in different times, the result is just going to be c times n. So yeah, so that's a nice property to have. We're going to use that. What else can we have? There's some others that are kind of useful, kind of similar. I goes from 1 to n of, let's just say, I. There's a formula here. Now, if we scroll back up here, I'm going to scroll back up here and point at this. So let's take a look at this number right here. 1 plus 2 plus 3 plus 4 plus 5 plus 6, okay? Let's actually add that up and let's see what we get. So, I'm going to have to do this in my head. Hopefully I'll get the right answer. Let's hope for the best. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. Plus 5 is 15. 21, 28, 36, 45, 55. Okay, so you get 55 here. Is that right? That's right. So there's actually a formula here that would give you the same answer. It will turn out that when you add these all up, put like blue here, it turns out that you add those all up and you get 55, but that's actually the same as if you do 10, the last number, times 11, which is the next number, and then divide by 2. So if you knew that you were going to stop at 10, you actually could figure out the answer quickly by just going 10 times 11 over 2, and you wouldn't have to add these all up the way that I just did, right? 1 plus 2 plus 3 plus 4 plus 5. Just kind of a neat thing. So there's a formula. Formula is, in this case, it's going to be I plus 1 over 2. Okay, and again, you could see different variables here, right? Like if they put a k, then k plus 1 over 2. I think they'll use a k, that's why I switched it to a k. So that's a good formula. And there's even one for like k squared, and even one for k cubed. But the further you go, the more complicated the formulas are going to get. So like actually this one I'm going to look up. because I don't remember things. Approximating areas, that's not what we want. Okay. All right, we did that, we did that, we did that. Yeah, we did all those. Okay, cool. There it is. Okay, so the formula is going to be k plus 1, 2k plus 1 over 6. And that's obviously more complicated, and I'm going to do the one for k cubed as well, just so we have it written down. This one's going to be, of course, going to be k squared, k plus 1 squared over 4. All right. Okay. So let's try to do some problems with these. Okay. Actually, let's not try to do problems. Let's just explain why these are true for a couple of them, or like let's look at them. So let's look at let's say property, like the first property. Um, so these aren't really problems; they're just kind of an idea of what's going on. So like um, if you had a sum, uh, well, it's hard to come up with one. Okay, fine. I'm just going to do this. Like, let's say we just had one that's 3 plus k. We're just going to use the properties. Okay. So let's say we're trying to do the sum of 3 plus k, and k is going to go from 1 to 5. Right? How would we work this out? Now you could just work this out just by adding it up by hand, right? So if we just add it by hand, which is a bad idea generally, but you can do it to check your answer. What would it look like? Well, we're going to put k equals 1 in here. So we're going to have 3 plus 1. So it's going to be 3 plus 1 plus. And then we're going to put k equals 2 in here. So 3 plus 2. 3 plus 2. And then we're going to put a 3 in. So it'll be 3 plus 3. And then 3 plus 4. And then we eventually get to k equals 5. And you're going to have 3 plus 5. 3 plus 5. Right? And then you can add these all up. So of course, this is going to be 4 plus 5 plus 6. 3 plus 4 is 7. 3 plus 5 is 8. So you have 4 plus 5 plus 6 plus 7 plus 8. So you add those up. 4 plus 5 is 9. 9 plus 6 is 15. 15 plus 7 is 22. And then 8 is 30. So we get 30. There's your answer, right? So that's always a possibility, is just adding them up by hand. But it'd be easier, and you're supposed to be learning these, to use the properties of sums. So let's use the properties of sums instead. Because if we change this number to like a 50, you would not want to be doing this problem with a 50 where that 5 is. So let's do this. So sum k equals 1 to 5, not 50, 3 plus k. So here's what we can do. So the first thing is we've got two things in here, the 3 and the k. Well, you can separate those because we have a property. The first property says that if you have a sum of two things added together, that you could split them up into two sums, right? You could put them together going from left to right, but you can also take them apart if you go right to left. So we're going to take them apart. So we can split using what I called property 1. It's probably not in the book. So split it into k goes from 1 to 5 of 3. I don't know why I put parentheses there. Plus the sum of k. K goes from 1 to 5. Let me just move this out of the way here. That. Okay. So you can split this into two separate sums. Now, why would you do that? Well, the reason you want to do that is because now each of these, this one and this one, can each be calculated using a formula up here, right? The K, this one, you can't see what I'm pointing at. The K here, we can use this formula for. And the 3, we could use this formula for. So we just need these two formulas. This one for the 3, this one for the K. So we'll use the formulas. So we'll use formulas, were they 4 and 5? I think they were. So let's figure out how to do it. So how do we do the sum of, how do we do the sum of 1 to 5 of 3? Well, look at the formula here. The stopping index is n, the constant is c, and the result is just cn. So you just look at this number and this number. So multiply those numbers, and that's the result. So down here, we're just going to be looking at the 5 and the 3, and using that formula, the answer is going to be 5 times 3, or 15. Plus, now we've got the sum from 1 to 5 of k. What's the formula? Well, come down here. Let's look at it. I'm now just realizing that I wrote these all wrong. We're just going to fix them. So what I did wrong here was, because I changed the letters around, but the stopping index was in. The stopping index is what gives you your formula here. Okay, those are all supposed to be ins, because that's what I used as my stopping index. I don't know why I screwed that up. So sorry about that. So if it goes from 1 to n, the n is going to give you what appears in your formula. That's a number, and you're going to know it. So let's write this down now. So for us, we've got, what do we have? Point is the n is going to be n and then n plus 1, right? So we've got a 5. So we've got a 5 up here. So n equals 5. So you're going to go 5 plus 1, which is 6, over 2. So what's the result? Well, 5 times 3 is 15. And 5 times 6 is 30 over 2, which is also 15. And then the result is 30. And so that's your answer, 30. That's what we got before. We got 30 up here. We get 30 down here. Okay? And that's how you use those properties. So like in the homework, well, in the homework, they're really obnoxious. They give you some that are kind of real puzzles. So this is straight off of the homework, and this is going to be a little bit tricky, but hopefully it will also be useful here. So they tell you this. Here's a problem straight off of the homework. They say, given I goes from 1 to 5, using 5 again, of 2 SI. And they don't tell you what SI is, but they say that this is 28. They say find the sum I goes from 1 to 5 of 3 SI minus 1. And so here's the thing. They both refer to SI and SI, and we don't know what SI is. So we're not going to be able to do much with those. What we're going to have to do is we're going to have to figure out what the sum of 1 to 5 of SI is somehow. And that's not going to be that hard. So our first step is going to be find this 1 to 5 of just SI using the properties of sums. Okay, so how is that going to work? Well, what we're going to do is we're going to take this first thing right here, and we're just going to write it down. So try that. Start here. 1 to 5 of 2si is supposed to be 28. Okay, that's what we know. But we should be able to do something with this 2, right? This 2 is extra here. What can we do with the 2? Well, using a property, we have a property that says that this 2 can actually just move to the outside of the sum, right? Isn't that property what I called property 2 here? If you have a constant out here, if you have a constant here, you can move it outside of the sum. So it moves from here to here. So we can move the 2. So we can move the 2 outside. That's a property. So this tells you that 2 sum from 1 to 5 of si is 28. So if that's true, then what is just one sum of si going to be? Well, we can just divide both sides by 2. So let's say that. Divide both sides by 2. So if we do that, I'll do it in a different color. So divide that by 2, divide that by 2. Of course, the point is that they cancel. So what do we get? We get just one sum from 1 to 5 of si is going to be 14. And you could have seen that up here, right? If 2si is going to give you 28, divide by 2, and you're going to get 14 here. So that should not be super hard, but that's your first step. Okay. Now, once you know this, we should be able to use this fact in order to actually answer the question. So we're supposed to be finding this thing, right? Because we know si now, and there's a 3 and a 1, but we know how to deal with those because we're smart. Okay. So now what do we do? Now we're going to use what we know to find, what was it? Sum 1 to 5, 3si minus 1? Yeah. Okay. So let's do that. So we start out with 1 to 5 of 3si minus 1. And we apply these properties. So we have one property that says we can split this up into 2. So let's do that. 3si. And then you could do, I'll do it this way, minus the sum I goes from 1 to 5 of 1. You have to be just careful. Like, do you put the minus here or do you put a plus here and the minus here? It doesn't matter. Just make sure you only have one minus sign. So I put it here. So minus, minus. Okay, so that was that property? Was that the first property? That was the first property. It was apply property 1. You don't have to say that. I'm just reminding you. Okay. We also have this number here can come out using property whatever, 4, I think. No, 3, 2, property 2. Right, the number can come out. So apply property 2. So you take the 3 out. I goes from 1 to 5. Si minus I goes from 1 to 5 of 1. And we should be able to figure these out, right? So this one right here, what is this? We figured that out already, didn't we? We figured out in the first step that was actually 14. The thing that I highlighted was 14. So you go 3. This is 14 because we already calculated it. That's why we calculated it. And then we have minus. We have this. But remember how this works. When you're adding up a constant, you just multiply the 5 and the number here and the number here, as long as it starts at 1. So 5 times 1. So what's 5 times 1? Of course, is just 5. So what do we get? 3 times 14 minus 5. So 3 times 14 is 42. 42 minus 5 is 37, I think. So that should be the answer. And that's not the easiest question to solve, but we're just using all these properties here. Let's do another one like this, actually. Maybe easier, I think. I don't know. So given, this is another one, same type. J goes from 1 to 12 of 4bj, so j, equals negative 16. Find sum from j goes from 1 to 12 of 3bj plus 2. And so that's another, it's exactly the same process. So the first thing we're going to do is we're going to find just the sum of bj. That's how we're going to start. So we're going to start with that given information, right? We're going to start with this. So let's write that down. So start with sum j goes from 1 to 12 of, what was it? 4bj equals negative 16. We know what to do now. You can take this 4 and move it outside. So 4 sum 1 to 12 bj equals negative 16. Then we're going to divide by 4. So you get sum j goes from 1 to 12 bj. We're dividing by 16. Sorry, we're dividing by 4. So negative 16 over 4 is going to be negative 4. Right? We're dividing this by 4. We're dividing this by 4. So you get negative 4. Then this right here, we're going to remember. And now we can actually solve what we're looking for. So we're supposed to be finding this. So this is the sum that they're asking us for. So we write it down. So we're going to find sum j goes from 1 to 12. It is 3bj plus 2. And we do it exactly the way we did the other one. So you're going to have j goes from 1 to 12, 3bj plus 2. You're going to split that into two sums. 3bj plus sum of 2. Then you're going to take out this 3. 3 sum j goes from 1 to 12 of bj plus sum j goes from 1 to 12 of 2. And then we're going to use our formulas. So we've got a sum here that we know how to do, and then we have a separate sum over here that we know how to do. We should be able to solve both of these. So we've got 3, and then the sum from 1 to 12 of bj. That's what we came up with already, right? The sum of bj is negative 4. So this is negative 4. And then we have plus. Now we've got the sum of 2. So from 1 to 12, we're summing up 2. Remember what to do. We just multiply these. 12 times 2 is going to be 24. So what do we get? We have 3 times 4 is negative 12 plus 24. So the result is going to be 12. And that's how these go. They're not that bad. We're just getting used to using these rules here. And the answers or the work in the book is going to be exactly the same as the work that we're doing here. All right, let's try a different type of the same kind of thing here. We're going to use different rules for this one. So here's another example. So they're giving us a couple of things. Given sum from 1 to 10 of 2 ci, don't know what ci is negative 4. And the sum from 1 to 6 of 2ci, same thing, is negative 14, and they want us to find the sum from 7 to 10 of ci. Right? So you can see that this is a little bit different than the previous problems here. So what's different about this one is we've got the indices changing, right? So you should notice that. I'm just going to write this. So note the indices are all changing. Indices are different. Okay, and that's kind of what this problem is about, the fact that those indices are different. But there's a rule that applies. One property can deal with that. One property will help. So let's look at the property here. So let's scroll up actually and look for it. So what's the property that will help us do this problem? It's going to be this one, number 3. Right? So this one's a little bit tricky here. It's 1 to n, and then n plus 1 to m, and then the final result is 1 to m. And that's confusing to look at. That's confusing to look at because of, too many letters. I, n, m, I plus 1. It's too much to look at. But it's actually very simple. It's actually very simple. So if I scroll down here, let's deal with this. So here's what the property says for our problem. So the property says this. I think it's 3, right? Tells us. What does it tell us? So what it'll tell us is this. It will tell us that if you go from 1 to 6 and then 7 to 10, so you go from 1 to 6 and then 7 to 10, isn't that all of the numbers from 1 to 10? So I'm going to write that in words, but then we're going to write it. A sum from 1 to 6 plus a sum, that's wrong sum, from 7 to 10 is equal to a sum from 1 to 10. And that should not be too complicated, right? If you add up 1 to 6 and then you add up 7 to 10, then you're really adding up everything from 1 to 10 because you started at 1 and did all the numbers up to 10. So you can write it as a single sum. So in notation, here's what that means. So we've got this one right here. So the sum, I goes from 1 to 6 of 2ci. If you add that to the sum from 7 to 10 of 2ci, right? This one asks for ci, not 2ci, but everything has to be the same down here. So I'm writing it correctly. So if you go from 1 to 6 and then 7 to 10, that is the same as if you started at 1 and went all the way to 10 in one step of 2ci. So again, make sure you pay attention to this. You have to use the same thing all 3 times. You could have used ci, 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 or 2ci, 2ci, 2ci. Doesn't matter. Just make sure you put the same one everywhere. All right, and hopefully this makes sense. So 1 to 6, 7 to 10, that's everything but from 1 up to 10. And then this is 1 to 10 directly. All right, so what are we going to do with that? Well, we've got some numbers to fill in. We have some numbers we can put in, I think. So what numbers do we have to fill in? Let me erase some of these scribbles. So what numbers do we have that we can fill in? Well, we've got this right here. right? 1 to 10, that's this one, I think. And then we've also got 1 to 6 here, which is this one. So we can fill in those numbers. So we fill in those numbers, and so 1 to 6, this one is going to be negative 14. So we have negative 14 plus, this one is actually not what we have, right? This is almost what we're looking for. We're supposed to be finding this. So we don't have a number here, so we just write it in with no number. Just write it the way it is. And then we've got this one, which is negative 4. So we do have a number there. So this is what we have. All right. So hopefully that makes some kind of sense. What can we do with it? Well, we can do algebra now. We can move some numbers around. So do a little algebra. Not a lot. We wouldn't want to do a lot of algebra. But what can you do? You can add 14 to this side and add 14 to this side. And what we'll end up with is on the left, we're going to end up with just the sum from 1 to 10 of 2ci, right? Because these are going to cancel. And on the right, we have negative 4 plus 14. That's going to be positive 10. So we just move the 14 over. Okay, are we done? We're not quite done because we have the sum from 1 to 10 of 2ci, and they asked for the sum. Wait, what has happened? Oh, I wrote this down, right? This was supposed to be a 7, and I wrote a 1. Right, so we have 7 to 10 of 2ci, and we're actually looking for 7 to 10 of just 1ci. So the 2, we have to fix the 2. So use a properties to get rid of the 2, which we've already done a variety of times. Variety? That's a weird way to say that. But take the 2 out. Take the 2 out. Like that. And then divide both sides by 2. And 10 over 2 is going to be 5. And that's going to be the answer. That's what we're asked to look for. Now, is that, quite a bit of work? Yeah, that's quite a bit of work. But, that's how they are sometimes. Okay. Now, this is only actually the first half of this homework assignment. There's more to it. But the topic is going to switch at this point, and we're going to be talking about something called Riemann sums. So I'm going to stop here, and I'm going to say next lecture is going to be Riemann sums. These are just sums. Okay, so that's it for right now. Good luck with your homework. I think I'm going to have to shuffle some dates around, so don't stress too much.